let's see. So what I was saying is that they all have the same base. That's the first thing you check. The first thing you want to check is that these all have the same base, and then you can see if you can combine them. And they all have the same base because if you don't see a number, that means it's 10 automatically. That's the default one. Now these two log terms are on the same side. So here, you want to combine them. And you want to see how they're being, like what's connecting them. And it's a subtraction sign that's connecting them. Whenever you have a subtraction sign, that should make you think about division. So what's happening is that you will write the log term one time. Like both of these will just be written one time here. So with the subtraction sign, now you're going to connect the two arguments together. This one will go on the top because technically there's a plus sign out here. So the one that has a plus sign in front of the log function will go on the top. This one will go in the denominator because this one has the subtraction sign in front of the log term. There's nothing to do on this side for now. We'll just leave it like this with the 7x plus 1. Now on the left side, if you want, you can put this in parentheses as well. All right. Now because we have the same log term with the same base, or not the same log terms, because we have a log function on both sides, no other terms, and they both have the same base, on this step, you can just go ahead and drop the log terms and focus on the arguments. There are a few more steps you can do in between to show how those log terms disappear, but at this point, you can just go to this point at this step. So the log terms are gone. Now we just have the arguments. And so with algebra, there are different ways you can solve this. What you can do now is just go ahead and multiply both sides by 3. So you put it in parentheses, and you put this part in parentheses. You'd multiply both sides by 3 now to get rid of that fraction. These cancel out, and what you have left is x plus 7 equals the 3 times 7x plus 1. And we'll just simplify it a bit. We don't need the parentheses on this side anymore because there's no modifier on the outside of the parentheses. On the right side, we have to deal with the 3. We have to distribute it. And you'll do this term by term. This will be 21x. This one will be 3. And now here, because this is the bigger number out of the two x terms, this one has a higher coefficient and it's positive, we'll just go ahead and subtract this one over to this side and keep the x terms positive. Some of these steps you can combine into fewer steps if you're comfortable with the process. Now here we'll subtract the 3 from both sides. So you have 4, and then here we have 20x. I'll rewrite that here for space. The next thing you want to do is go ahead and divide by 20 on both sides so that you can get the x by itself. On the left side, this will reduce because both the top and the bottom can be divided by 4. 4 divided by 4 is 1. 20 divided by 4 is 5. Now, what's important is that you have to check this. Because the original equation started off as a logarithmic equation, you'd need to check that this answer will work within the domain. So you could either check it as an entire equation where you plug the 1/5 into every x, Or you could do a term by term, which is generally a little faster. So what you do is you take every log term, and we're not writing it as an equation, we're just writing the separate log terms like this. And you check this in every single one of these. Now, just for the purposes of this part, 1/5 is the same as 0.2. And so that would make it just a little bit easier to see what's going to happen here. You could keep the fraction and deal with common denominators, but this will just speed it up a bit. So what you're doing is you're plugging in the 0.2 wherever there's an x. And you're seeing if it stays a number greater than 0. This is greater than 0, so this works so far. Now we have to check the next one. Here there's no x to plug in the 0.2 into, so this one's already set. And then here you're going to do this. Now if you notice, it's going to multiply it with a positive number and then add to another positive number. And so this will stay positive. Then you're all set. You don't have to figure out what that is. But if you wanted to, this would turn into 1.4, and then when you add the 1 to it, it becomes 2.4. It's greater than 0. As long as this is greater than 0, then this is okay. The 1/5 worked in all, even though I used it as a decimal just for this specific part. The 1/5 worked in all of these, so that means that we know that this is going to work as the answer, and so you can be satisfied with this now.